With all of the videos in this series, it's really important that you take notes as you're watching the video, and ultimately the best way to learn is to watch the videos in the lab or in front of your own personal copy of Pro Tools, and when I demonstrate something, then stop the video and do the exact thing that I just did in the videos on your own machine. So that way you're really engaged in the video and in the learning process, and you're being demonstrated how to do something, and then you're doing it yourself. And that way, hopefully, it'll stick in your head a little easier than just reading a book or watching a video and then trying to remember what was in the videos a week later when you go to the lab or when you open Pro Tools. The next thing that's really important is that you spend a significant amount of time using the application. We will be using it in class, in almost every class period. And so it's important that you have watched the videos, taken quizzes, and that you are completely prepared to come to class and work on an in-class assignment. That's what we'll be doing in class time most of the time. Before we dive into Pro Tools, one of the first things we need to do is take a review of digital audio, what it is, how it works, and some of the terminology that's used when you talk about digital audio. Some of those terms include sample rate, bit depth, frequency, amplitude, the Nyquist theorem, things like that. Sound really can be defined as the change in air pressure. So let's talk about this for a second. If you take any instrument, let's say a piano, you hit a string, the hammer hits the string, and then that string vibrates left to right like this, or up and down. It just vibrates. And as it vibrates, it's forcing the air around it to move. Okay? So when it's pushed to this side, you have positive pressure, and this side negative. And then when it pushes to this side, you have positive pressure over here and negative pressure here. So that string, as it vibrates, is moving air. And our ears are able to perceive that movement of air, and we understand or we hear that as sound. So sound is just the movement of air. To record sound, then, we need to be able to capture these changes in air pressure. We do that through something called a transducer. A transducer converts one type of energy into another. In this case, the changes in air pressure we convert to changes in electrical signals. Okay? So we do that through a transducer. The most common transducer, one you're very familiar with, is the microphone. The reason you're able to hear me right now is we're converting the changes in air pressure as my vocal cords hit and make sound. They're actually changing the air pressure coming out of my voice and out of my mouth. And when it hits the microphone, it's moving a small diaphragm in that microphone that converts those changes in air pressure to changes in the electrical signal. So it converts it using a transducer from air pressure changes to electrical changes. That's how we wind up with the term analog sound. Analog sound means essentially that the sound that we are generating via an electrical signal is analogous or similar to or identical to the original changes in air pressure from the original sound source. So once we've converted our changes in air pressure to an electrical signal that's analogous to those changes in air pressure, then basically they create what's called a waveform. So positive air pressure changes, or in this case positive electrical changes since we've converted it, and then when it goes down below the center line, we have negative air pressure changes. That creates a waveform. So every sound produces a waveform, and that waveform represents graphically what the sound actually sounds like. Now, most of these are complex waveforms. For the purposes of learning, we're going to talk about waveforms in the simplest term. So we'll use a waveform that looks like this. Anything that is above the center line is positive pressure. Anything below the center line is negative pressure. Okay, so that's a really basic waveform. Okay, here are some basic waveforms from a drum kit. So as we look at these waveforms, there's a couple of things we need to pay attention to. One is the height of the waveform above the vertical axis. We're going to discuss that in depth in just a minute. And then the next thing is how often the waveform repeats itself. So this is called one cycle. We're going to go into this again in more detail. This is another cycle. So that's one complete waveform. We're going to talk about that more in detail in just a minute. You'll also notice that these waveforms are relatively complex. They're not simple like the waveforms I diagrammed with my finger in the air just a minute ago. So all waveforms are essentially complex, and they consist of two things: the information above the center line and below the center line, or the information on the vertical axis, and the information contained on the horizontal axis.